Welcome to the Chemistry, Biology and Math Revision Hub. Today we're doing the Pearson Edexcel International A-Level Chemistry Unit 2 for October 2024. Let's begin with the first question. In question 1, a Maxwell-Boltzmann curve showing the distribution of molecular energies is shown. So this is the graph, ignore the part in blue. They say what happens to the curve when the temperature is increased. Increasing the temperature will shift the curve towards the right and the peak is going to be lowered. So the answer here is going to be C, further to the right, and the peak becomes lower. Then they say how does the diagram change if a catalyst is added? Addition of a catalyst, of course, the activation energy is going to shift to the left. So here the activation energy moves to the left and the peak stays the same. Of course, the peak is not affected. So the answer is a C. In question 2, the equilibrium between methane and steam is shown. The first part says what would be the effect of lowering temperature. If we see here, the forward reaction is endothermic, and if the temperature is decreased, the equilibrium position is going to shift to the left, decreasing the yield. So my answer is the yield is going to decrease, but also the rate, because when temperature is lower, there is less kinetic energy, and so the rate of reaction decreases. So the answer is D. Rate decreases and yield decreases. In part B, what would be the effect of increasing pressure? So here, increasing pressure shifts the equilibrium position to the side with fewer gaseous molecules. So this means it's going to shift to the left, meaning the yield is going to decrease. So my answer is rate increases, yield decreases. The reason as to why rate increases is when you increase pressure, the particles are going to be closer together, meaning there are more collisions. However, in this case, we are going to be producing more of the reactants and other products, so the answer is B. Rate increases, the yield of the product decreases, since that position shifts to the left-hand side. In part C, some bond enthalpies are shown. So we have the table here, and they say what is the bond enthalpy in kilojoules per mole for the carbon-hydrogen bond. If we go back to the beginning, which is going to be this reaction here, I rewrote it here, but the bonds were displayed. So to find the enthalpy change is going to be the sum of the bonds which are broken from the reactants minus the sum of the bonds which are formed in the products. So 4 times the carbon hydrogen, which we are looking for, plus 2 times oxygen hydrogen minus the 10774 CO plus 3 times the hydrogen. This is what we see here. And this is going to equal to the delta H, which we were given here, positive 206 kilojoules per mole. I put it here. And then rearranging and making carbon hydrogen the subject, we have CH, 4 of them, equals 1663. Basically here you just have to add and then subtract from that and create this. And in the end we have 4 carbon hydrogens equal 1663, divide through by 4 to find the equivalent of 1. And it was approximately 416, so the answer is a C. In question 3, which equation shows the reaction that occurs when the standard enthalpy change of formation of copper 2 carbonate is measured? Now when they say standard enthalpy change of formation, it means 1 mole of copper 2 carbonate is formed from its elements. Since it's copper 2 carbonate, we'll need copper, which is a solid, carbon solid, and oxygen, which is a gas. So here carbon being a gas is out. And here we're forming 2 moles, that is out. The part here where oxygen is O and not O2, oxygen should be O2, that is also out. So the answer should be this one here, D. In question 4, which statement about group 2 elements and their compounds is true? Let's see, the first one says calcium hydroxide is less soluble than magnesium hydroxide. That is wrong. Magnesium hydroxide is less soluble. And then B, all group 2 metals give characteristic flame colors. No. Magnesium, beryllium do not. Magnesium carbonate does not thermally decompose when heated. It decomposes. And D, the first ionization energy of magnesium is greater than that of calcium. That is true because first ionization energy decreases down the group. In question 5, a compound which is a white solid gives a red flame test and produces a colorless acidic gas when heated. Producing a gas when heated could be thermal decomposition, so I'm going to give it to a carbonate because colorless and acidic. Other gases like nitrogen dioxide and so on that could be acidic, have a certain color. So I would go with this because it's thermal decomposition So I'm thinking it's a carbon dioxide gas coming from a carbonate. But the red flame could be strontium, calcium. So let me see which one is paired with a carbonate. Calcium carbonate, okay. Here, sodium, no, out. Sodium is out. Strontium is paired with nitrate, calcium nitrate. That's also, the answer should be A. In question 6, which statement explains the origin of a flame test color? A flame test color comes as electrons that have transitioned return from the excited state to the ground state. They release energy or a photon of light, which has a wavelength corresponding to a color in the visible region. So the answer is D. They emit energy as they drop to a lower energy level. In question 7, sulfuric acid and sodium hydroxide react as shown below. Which sample of sulfuric acid will be exactly neutralized by 20 centimeters cubed or 0.5 mole per decimeter cubed sodium hydroxide? Now I will begin by finding the number of moles in this, which is concentration 0.5 times the volume, of course divide by 1000 to convert it to decimeters cubed, giving us 0.01 mole. Now since this is sodium hydroxide 0.01 mole, the sulfuric acid should be half of that based on this equation. The ratio is 1 to 2. So the moles we are looking for should be 0.005. So from the table, I calculated the moles of this. It's going to be concentration times volume. I got that, which is what I'm looking for actually. I looked into this and it was different. So I just straight went away with A because it's the one that gave me an answer I was looking for. In question 8, a 20 gram sample of iron 3 sulfate was dissolved in water. How many sulfate ions are in the solution formed? Now here we have the mass. They've given us the MR, so I need to find the number of moles, which is 20 divided by 400, giving me 0.05 moles. But this is the number of moles of that whole thing, but in each there are 3 ions of sulfate, so 3 times 0.05 gave me 0.15 mole. I'm talking about of the 3. Then we multiply with Avogadro's constant, so that times Avogadro's constant gives 0.903 times 10 power 23. If you write in standard form, it's 9.03 times 10 power 22, and so the answer is B. In question 9, which substance is formed when concentrated sulfuric acid reacts with solid potassium chloride? If sulfuric acid reacts with a chloride, this is going to form potassium hydrogen sulfate. These are not formed in this situation because, of course, chlorine is not going to be formed since that is not a redox reaction. So the answer is going to be D. In question 10, what is the color of the solution formed when iodine dissolves in cyclohexane? Cyclohexane is an organic solvent, and when iodine dissolves in an organic solvent, the color is going to be purple. Next, which alkane has the highest boiling temperature? We'll look at all the examples given. This has 7 carbons, pentane 5 carbons, 2-methylpentane 6 carbons, and 2,3-dimethylbutane. Butane 4 plus the 2 in the methyls gives 6 carbons. So this is out because it has fewer carbons, fewer electrons, and fewer London forces. These two have 6, so I'm going to go with the one with the most numbers of carbons because it has more electrons or a higher molecular mass, and therefore more London forces. Another thing, remember, all these compounds here only have London forces, so the one with more carbons is going to be the winner. In question 12, what is the name of the alcohol shown? This alcohol here, we're going to give OH priority. I numbered from left to right, and this got 3, that 4. Then when I did right to left, this got 3 and that 4. Since we're giving OH priority, I'm going to go with 3 for OH and 4 for the methyl. So the name should be 4-methyl, 1, 2, 3, 4, 5, 6. That's going to be hexane. So 4-methyl hexane 3O. The answer is B. In question 13, they say chloroethane reacts with aqueous potassium hydroxide to produce ethanol. What is the role of the hydroxide ion in this reaction? In this reaction, because we are producing ethanol, it's a substitution reaction where OH comes in as a nucleophile in the nucleophilic substitution reaction, so the answer is B. In part B, which mechanism shows the correct movement of electrons in this reaction? So because this is a substitution reaction and not elimination, the OH gives electrons to the electron deficient carbon, so this is wrong. This one here is wrong as well. electrons come to the carbon that is electron deficient in this bond, correct? And this is also wrong, so the answer should be C. From here to this partially positive carbon, and then that bond breaks away. In question 14, this question is about 4 organic compounds. So we have propan-1-O, which is primary, propan-2-O, which is secondary, propanaldehyde, and propanone, a ketone. They say which compound would not give a color change when heated with acidified potassium dichromate 6 solution. This is an oxidizing agent, so the propanone cannot be oxidized, and therefore the answer is D. Next, which compound could give a peak at mass to charge 31 and mass to charge 60? When we see mass to charge 31, always remember CH2OH. This is usually a primary alcohol. So among these, this is the only primary alcohol. And if you consider the mass to charge, of course, we will see 1 at 60. So the answer is going to be A. In question 15, an infrared spectrum of a compound containing one functional group is shown. So here they say, which functional group is most likely to be present in this compound? They want you to refer to a data booklet. In this case, a functional group could be anything. We see this part here, which could be OH, and this part here, which could be CO. So, because it has both, it could be a carboxylic acid. It's not going to be an aldehyde because this won't show OH, this will not show the CO, and this will not show the OH, so it's a carboxylic acid. In question 16, this question is about magnesium sulfate, a white ionic solid that is very soluble in water. Hydrated magnesium sulfates have the general formula, which is that, where X is the number of water molecules of crystallization. A sample of hydrated magnesium sulfate was heated until all the water had been removed from the crystals. The mass of the sample decreased from that to that. State how you could ensure that all the water had been removed from the crystals. This is done by heating to constant mass. And next they say calculate the number of water molecules of crystallization X in the formula of this compound of hydrated magnesium sulfate. Here I wrote the equation. We see if all the water has been taken out, will form the anhydrous magnesium sulfate. And from above here, they've given us the masses, so 6.92 to 6.04. So we can use that to get the mass of water that has been taken out, which is 6.92 minus 6.04, giving us 0.88. So I'm going to find the moles of this and the moles of that and get the ratio. The ratio will be 1 to X. So moles of water are going to be 0.88 divided by 18, giving us that. And the moles of magnesium sulfate, we have the MR here. So it's going to be 6.04 divided by 120.4, giving us that. And the ratio is going to be that to that, giving us 1 to 1. So the value of X is going to be 1. In part B, the most common form of hydrated magnesium sulfate is magnesium sulfate with 7 water molecules. A student carried out 2 experiments to determine the enthalpy change when anhydrous magnesium sulfate forms magnesium sulfate, which is that. In the first experiment, the student determined the enthalpy change when dissolving anhydrous magnesium sulfate. So 100 grams of distilled water was placed in a polystyrene cup and the temperature recorded. This is 0.0628 mole of anhydrous magnesium sulfate was added to the distilled water. The mixture stirred and the maximum temperature recorded. So we see the starting temperature and the highest attained temperature. They say calculate the enthalpy change for this reaction and give your answer to an appropriate number of significant figures and include a sign and units. They've given us the specific capacity and the density of the solution is 1 gram per centimeter cubed. So to find Q, which is the quantity of heat released, it's going to be M times C times delta T, but we have the mass here and the specific capacity is given here. And of course the delta T, which is that minus that, to give us that. Using a calculator, I got 5350.4, which is in joules, and then I converted it to kilojoules by dividing by 1000. Next, to find the delta H, it's going to be negative Q over N. It's negative because the reaction is exothermic since the temperature increased. So that, divide by the number of moles given here, I got negative 85.2 rounded off to 3 significant figures. Then, in the second experiment, the student determined the enthalpy change when dissolving hydrated magnesium sulfate. we see that being dissolved. So they've given us the Hess cycle and they want us to complete it. So for this reaction, we can see this part here is going to be this reaction here. Hydrated is being dissolved to produce the magnesium sulfate, which is aqueous. So the delta H is for that. The one we've calculated previously is for this. So we are looking for this one here. So to find that, it's going to be that plus the negative of this. So they say calculate the enthalpy change when anhydrous magnesium sulfate forms hydrated magnesium sulfate using the completed Hess cycle, and your answer in B. So this is going to be negative 85.2 plus negative 15.8 or minus positive 15.8, which gave us negative 101 kilojoules per mole. And in part C, magnesium sulfate is very soluble in water. Draw a label diagram showing how both the magnesium ion and the sulfate ion interact with water. Water is polar. We have the partially positive hydrogens and the partially negative oxygen. So the negative sulfate will be closer to the partially positive hydrogen, and the positive magnesium is going to be closer to the partially negative oxygen. Then they say barium ions are toxic in aqueous solution. If a solution containing barium ions enters the body, barium poisoning occurs. Describe how drinking magnesium sulfate solution can reduce the extent of poisoning. Magnesium sulfate is going to provide the sulfate ions, and these are going to react with the barium ions, forming barium sulfate, which is insoluble, thereby extracting it out of the solution. So I said magnesium sulfate provides the sulfate ions. These react with barium ions, precipitating them into insoluble barium sulfate, and the reaction is barium 2 plus aqueous plus sulfate. Aqueous gives us barium sulfate, which is a solid. In question 17, this question is about two halogenoalkanes and B, which have the structures. We have that and that. Name compound A. Compound A, this is the longest chain, 3 carbons. The iodine and the methyl are on carbon 2, so it's going to be 2-iodo, 2-methyl propane. They say draw the skeletal formula of B. B has 1, 2, 3, 4 carbons, so 1, 2, 3, 4, and then connecting a bond to Cl. So in this case, remember we exclude the hydrogens, we exclude the carbons when we're writing the skeletal formula, but we include the functional group like Cl. The next they say describe what you would observe when separate samples of A and B are warmed with silver nitrate dissolved in aqueous ethanol. Now sample A has iodo, so when we use silver nitrate, the iodide is going to react with silver to give us silver iodide, which is yellow. With B, which is chloro, of course, a white precipitate is going to be formed, and that is silver chloride. And next they say give 2 reasons why A reacts more quickly than B when warmed with silver nitrate dissolved in aqueous ethanol. To take you back, so when we look at this, it's a tertiary halogenoalkane, we can see, and it's a carbon iodide bond, meaning it's going to be weaker because the Ci bond is weak, plus being tertiary causes this bond to break easily. So I said because A is a tertiary halogenoalkane and the CCl bond it contains is weaker, it therefore releases the Cl ion faster, allowing it to form silver chloride with silver nitrate. Then they say write an equation for the reaction of B with an alcoholic solution of potassium cyanide and name the organic product. So it's carbon 4 hydrogen 9 Cl. When it reacts with KCN, we see carbon 4 hydrogen 9 CN. This is a substitution reaction. One nucleophile CN comes in and replaces another nucleophile Cl. The product formed has 1 extra carbon, but it's a nitrile, so it's going to be pentane nitrile. Then they say suggest why this type of reaction is important in organic synthesis. It increases the length of the carbon chain because we started with 4, but now we have 5 carbons. In question 18, the student determined the molecular mass of an unknown volatile organic liquid X using the apparatus shown. The student used a hypodermic syringe to inject a sample of liquid X into a gas syringe. The gas syringe was placed in an oven and liquid X was vaporized. So this is the syringe, the hypodermic syringe, and this is the gas syringe. And these are the results we have. This is the mass, syringe and liquid before injection. This is after injection. Mass of the gas in the syringe. We have the temperature, we have the pressure, and the volume. So they say calculate the relative molecular mass of X. I'm going to use the values from the table. They want us to use this formula. So PV is nRT, and therefore N is equal to PV over RT. From the table, pressure given is 99 kilopascals. Multiply that by 1000 to convert it into pascals. The temperature is 95 degrees Celsius. We convert that to Kelvin by adding 273, giving us that. The volume is 81 centimeters cubed. Convert it to meters cubed. So divide by 1 million, and we get that. So number of moles is going to be P times V divided by R. We have R here times T, and I get this as the number of moles. From the table, we have the mass of the organic liquid as 0.12 grams. So the molar mass is going to be the mass, which is that, divided by the number of moles, giving us 45.8 gram per mole. Then they say each molecule of X contains carbon atoms, hydrogen atoms, and 1 oxygen atom. If we take away 1 oxygen, which is about 16, we are left with about 30, or you'd say 29 point something, and that means that is CH3CH2. So it's going to be ethanol. Next, they say this question is about group 7 halides. The table shows the boiling temperatures of some group 7 halides. The increase in boiling temperature in these hydrogen halides is due to London forces. Describe how London forces arise. London forces arise as a result of an even distribution of electrons or charge within an atom that causes an instantaneous dipole in one molecule, and therefore an induction of a dipole in the next molecule. So I said London forces form due to unsymmetrical distribution of charge that occurs as electrons randomly arrange themselves within atoms. This arrangement leads to instantaneous dipole formation in one molecule and an induction of dipole in the neighboring molecule. Then, state why the London forces in hydrogen iodide are stronger than those in hydrogen chloride and hydrogen bromide. This is because hydrogen iodide has a larger or higher molecular mass, or you could say it has more electrons. So if there are more electrons, it means more London forces are going to be formed overall. And next they say the boiling temperature of hydrogen fluoride is plus 20. State what causes hydrogen fluoride to have such an unusually high boiling temperature. This is because hydrogen fluoride can form intermolecular hydrogen bonds. In part B, they say chlorine reacts with water as shown. We see this reaction. Explain why this is a disproportionation reaction by referring to the relevant oxidation numbers. Referring back to the equation, this is oxidation state 0. In here it's plus 1, and that is minus 1. So moving from here to that is oxidation, and here to that is reduction. Since the stem species is oxidized as well as being reduced, that is going to be a disproportionation reaction. And the next part, state and explain what happens to the position of equilibrium when sodium hydroxide solution is added to this equilibrium mixture. When you add sodium hydroxide, remember these two are acids. The sodium hydroxide is going to react with the hydrogen ions from these acids, thereby decreasing the concentration of the product and so shifting the equilibrium position to the right to generate more of those products. So I say the added sodium hydroxide reacts with the hydrogen ions from the acid products. This shifts the equilibrium position to the right. More HCl and HOCl are going to be made. In question 20, this question is about lithium and some of its compounds. Lithium has an atomic number 3 and is the least dense of all the solid elements. Lithium hydroxide solution can be made by reacting lithium with water. Write an equation for the reaction that occurs. Include state symbols in your answer. So the reaction is going to be, of course, lithium a solid plus water a liquid, giving us lithium hydroxide, which is aqueous, plus hydrogen gas. So balancing it, this is going to be half. Then they say give 2 observations you would make during this reaction. Because hydrogen gas is formed as the solid moves on the surface, this is going to be fizzing, or some people could say bubbling. The solid is going to float on the surface of the water because lithium is less dense than water, and then the solid would decrease or it could disappear as the reaction proceeds. Then they say lithium metal is stored under oil. When a piece of lithium metal is removed from the oil, the surface quickly tarnishes. One compound formed is lithium nitride. State how lithium nitride is formed, including the formula of lithium nitride. So it's going to be formed as lithium reacts with nitrogen in the air, and it's Li plus N3 minus, so the compound is going to be Li3N. In part C, mobile phones rely on rechargeable lithium batteries. The cell of one type of battery consists of one anode containing a compound of lithium and carbon, and a cathode containing cobalt oxide. The two electrodes are kept apart by when the cell is in use, the current flows at the anode. The lithium atoms lose electrons and form lithium ions. The ions travel through the separator and the electrons travel through the external circuit to the cathode. At the cathode, the cobalt oxide combines with lithium ions and electrons and forms this compound here. So we have the setup, and they've given us some of the equations. We can see this is oxidation since electrons are lost, and this is reduction since electrons are gained. They say give the overall equation when the cell is being used. So here, since one electron is on the right here and one electron to the left, we just combine the two equations the way they are. So this plus that will equal to that plus that plus that. I'm adding the things on the left separately, and then the things on the right separately to create this equation here. The electrons have cancelled out because they are the same, and the lithiums have also cancelled out, leaving this as the general equation we're looking for. And they say describe with reference to oxidation numbers what happens to cobalt when the cell is in use. Here cobalt is +4 oxidation state. You can see each oxygen is -2 since there are 2. So -4, that should be +4 to make the compound 0. And this one here, we have +1, and then we have +3, -2 for each, so this is going to be +3. So cobalt is reduced from +4 oxidation state to +3. Then they say suggest one property the separator must have to ensure that lithium battery is viable. The separator should allow the lithium ions to go through, so it must be porous. In part D, lithium is often added to aluminium to make aluminium-lithium alloys. These alloys have a variety of uses, including aircraft manufacture. One alloy contains only aluminium and lithium. It contains 2.45% lithium by mass. So if it contains aluminium and lithium alone, and this part is lithium, the remaining one should be aluminium. So they want to calculate the mole ratio of aluminium to lithium in this alloy. So the percentage of aluminium is going to be 100 minus that, giving 97.55. And so the number of moles, aluminium will be 97.55 divided by 27, giving us that. And for lithium, 2.45 divided by the atomic mass 6.9, giving us that. Then we do the ratio, which is that to that, giving us 10:1. And next they suggest a reason why this alloy is better than pure aluminium for aircraft manufacture. Aircrafts prefer things that are light and are going to be strong, so if this alloy is better, it's going to be lighter and maybe stronger. And in part E, they say compounds of lithium, which is a group 1, and compounds of magnesium, which is a group 2, have similar properties. Explain why the ionic radii of lithium and magnesium are similar. Now, if you look at these two, magnesium ion has an extra shell, but lithium doesn't. However, this has a 2+ charge, and this has a +1, so this attracts the electrons in the outer shell more, making it smaller, so they have almost similar ionic radii. Then they say the thermal decomposition of lithium nitride is similar to that of magnesium nitride, but different from the thermal decomposition of sodium nitrate. Now again here, when we look at lithium and magnesium, for lithium, it has a high charge density. Magnesium as well has a high charge density because of 2+ charge. So the two are going to decompose the same way because they have the ability to cause polarization on the nitrate. On the other hand, they say, but different from thermodecomposition of sodium nitrate, sodium has +1 charge. Its ionic radius is not going to be that small, and so the polarization is going to be weaker, so the decomposition is going to occur differently. So I said magnesium ion has an extra shell than lithium. However, magnesium ion has +2 charge while lithium has +1 charge. The higher charge leads to a decrease in the ionic radius, resulting in similar ionic radii in magnesium as in lithium. Then thermodecomposition of lithium in magnesium nitrate both occur to form metal oxide, nitrogen dioxide, and oxygen. The equation for the decomposition for lithium nitrate is that, and for magnesium nitrate is that. On the other hand, sodium nitrate decomposes producing sodium nitrite and oxygen only, meaning it does not produce the nitrogen dioxide, nor does it produce metal oxides. It produces metal nitrite. So sodium nitrite, which the equation is here, the greater charge density on magnesium and lithium cations polarizes the nitrate more. They therefore decompose in a similar manner. Sodium ion, on the other hand, has less charge density and polarization is weak, so its decomposition is going to be different. So this brings us to the end of this paper. Thank you for being with us. Do not forget to subscribe. See you in the next video. Bye-bye.